Hello, this is Gary Templeton, and this is the first chapter in BIS 3233. It is an introduction to information systems. This chapter in this class offers a tremendous amount of terminology, and you will need to be aware of the terminology, but also understand the specific differences between them. And a good example of this is information technology versus an information system. An information technology refers to any computer-based tools that people use to work with information and to support the information processing needs of an organization. So it's technology that supports individuals and the organization. But information systems involve people, culture, and organizational structure as well as the information technology. So information systems is a more comprehensive view of the world we live in with the technology that we use. Chapters will begin with a case. In chapter 1, the opening case is AngelList. AngelList's mission is to make startup investing transparent and efficient. So what it does is it matches people who are interested in starting a business with investors. And as you will find, as you learn more about these different applications of technology, and there are thousands and thousands and perhaps millions of these applications of technology that are out there in the world. So as you learn about each one of these, you will find that each one has specific terminology associated with each one. And for example, AngelList brings angel investors to the world. An angel investor is an individual who provides capital for a startup, usually in exchange for convertible debt or ownership equity. So if you are interested in starting a business, especially a technology related business, you can go to AngelList and be connected with angel investors. On AngelList, a wealthy investor is known as a lead. So you can see from this explanation that technology oftentimes will connect people to this whole worldview for which they can become familiar. The first section in this chapter asks the question, why should I study information systems? Well, it's very simple. We want to become an informed user. Being an informed user means you're knowledgeable about information systems and technology. It doesn't mean that we are going onto Facebook and reading posts and posting information. We also need to understand the technology. Whereas it's important to be able to access information on the internet, it's also important to build information technology, to be able to communicate with others about information technology, to train others, to understand the importance, to understand security about information technology. These are things that we will learn about this semester, but there are more facets to becoming an informed user than just downloading content. It can be very helpful and empowering to students to know about the career opportunities in information technology. In recent years, prominent publications have ranked the best career opportunities. For example, Forbes magazine, out of 12 professions, listed software developer as number 1. It also listed web developer as number 6, database administrators as number 8, and information security analysts as number 12. U.S. News and World Report listed software developer as number 3, computer system analyst as number 7, information security analyst is number 8, web developer number 11, and IT manager number 21 out of 100 professions. Money magazine in the top 20 listed software architect number 1, and also in the top 20 was database administrator, clinical application specialist, that is IT and healthcare, user experience designer, and IT program manager. You can see from these examples that developing, managing, understanding, training people in information technology can be quite empowering. But also, let's not forget that there are a lot of professions out there even doctors who are now using robots to do surgery. They're doing that extensively now with the Da Vinci surgical robot. There are many, many professions that aren't explicitly involved with technology development, but they have infused information technology heavily in their jobs. Table 1.1 in your book, it's on page 6, lists several IT-related jobs. These are jobs where people are explicitly tasked with IT development. These are career opportunities in information technology, dealing with the development and diffusion of information systems throughout society. So perhaps the most prominent is the Chief Information Officer. This is the highest ranking information systems manager. Chief Information Officers are highly ranked and are among the highest paid and most prominent managers in modern businesses. Also, applications development managers. These people coordinate and manage new system development projects. IS directors manage all systems throughout the organization and the day-to-day operations of the entire IS organization, meaning the IS department or the IS function. The traditional function of the MIS department is staffing, training, and developing IS skills. So that is something the IS director will be involved with. Also, educating the MIS staff about the business is a new and consultative function in the MIS department. IT can be used to create a competitive advantage when it is used effectively, and we will learn a lot about that this semester. Career opportunities in IS are strong and are projected to remain strong for the next 10 years. Table 1.2 shows the changing role of the IS department. As you can see here, there are 6 disciplines that are prominent in businesses. These are functional areas. What I mean by that is they are somewhat independent. They are distinct disciplines, and we see these majors in colleges all over the world. Accounting, for example, is a distinct discipline with their own terminology. And a lot of people think that accounting is similar to finance, but if you talk to accounting and finance people, they will say that their discipline is very different. The disciplines are very different. Marketing, people who do marketing are more extroverted and want to reach out and get people to do something. They want to entice people to buy a product. Production and operations management, these people are interested in operational efficiency, of course extraordinarily important in any business. HRM, these are people who like to deal with people. All of these disciplines use MIS, and MIS is its own distinct function, as you can see from this diagram. There's a case in this section that shows the importance of functional areas. The case on information technology supporting students in Georgia describes a CIO, or Chief Information Officer, who believes the best way to collaborate with 31 independent-minded university CIOs is to look for scenarios where 3 to 5 universities are planning to purchase the same product and therefore can consolidate their buying or centralize their service. One specific example of how the CIO utilized this strategy to resolve a problem was to develop a centralized system for student registration. So whereas several of those schools had the same redundant student registration system, just with different data but the same functionality, they thought it would be important to integrate all of those systems into one to make it more efficient and easy to manage. Changes like this can save organizations millions and millions of dollars. Section 1.2 offers an overview of computer-based information systems. It provides some important terminology that you'll need to be aware of in your career as you interact with people who build, manage information technology, and as you use it. For example, data items. As you're walking to the cafeteria to pick up your lunch, you see a poster with the word apple on it, with a picture of an apple below it. You may not think about it at this time, but this is a data. Information is a little bit different because information is data, but that is described more and that is more rich. It may be many different records of data, and for example, it might be the average of prices, or it might be the standard deviation of transaction amounts. So information attempts to summarize data. And then there's knowledge. We can use information technology to take the information to produce knowledge. And what that means is we are looking at relationships between the different variables of interest. More terminology is a computer-based information system. This is a general term for any information system that is computer-based. It's self-explanatory. So an information system is a very broad term that actually comes from biology. A bird, for example, is an information system. You are an information system, especially when you take notes. But if it's computer-based, that's a different class of information system. An information technology component is the raw material for an information system. It is the hardware, the specific software, the database, networks, procedures, and people. And we bring these together to build information systems. An information technology platform might be several applications that talk to each other in a sort of software ecosystem. Information technology services are any type of actions, non-physical product that is the result of information technology development. For example, when we use Facebook, that is a form of an information technology service. Information technology infrastructure. This is the IT components, the IT personnel, and IT services. An application or app is self-explanatory. It means that we are applying information technology to a problem area. For example, we can apply information technology to baseball scorekeeping. This section also provides ways that we can classify information systems. For example, there's the functional area information system. I described functional areas a little bit earlier: accounting, finance, operations. We build information systems in these specific domains of the organization. ERP systems, or enterprise resource planning systems, are designed to correct a lack of communication among the functional area information systems. This is necessary because these functional areas built their own systems over the years, and these systems did not talk to each other. ERP allows the systems to come together with a unified database so they would talk to each other. Similarly, transaction processing systems have also been developed to integrate all of the different functional areas of the organization. At a larger level, we have interorganizational information systems. These are attempts to bring multiple organizations together so their systems will interoperate. We have systems specifically for the supply chain. We'll talk more about that this semester. What becomes apparent in this description of information systems is knowledge workers. It's important to know that there are different classes of workers that are specifically valued through their understanding of knowledge. Knowledge is developed through learning and is the experience and expertise that managers can apply to business problems. And we get a tremendous amount of knowledge and experience from information systems because this is often the eyesight of our organization. We build systems to support office work. We've been doing that for decades. This is called an office automation system. We have business intelligence systems where we're simply trying to support various forms of decision making. For example, an expert system automates decision making processes. A cutting edge way of organizing our information systems is the dashboard, which is the capstone information system in an organization. This is where we monitor real-time data changes to operations in the organization, for example. The chapter contains a case. You have several cases that are referred to as an ongoing theme known as "It's About Small Business" or "It's About Business." This example is Warby Parker. Warby Parker is a competitor to LensCrafters. Warby Parker can offer cheaper glasses than their competition because they use the same materials in factories as Luxottica without the licensing fees. This is an example of how a company can use information technology to cut into competition. This industry typically has been in the form of an oligopoly, which refers to a small number of companies that dominate the business and are making large margins. This is not a hopeless situation, as we can apply information technology to enhance our own market share. This slide shows the relationship between IT components, personnel, services, transaction processing systems, and the functional areas. You see we have foundational components at the bottom, and the thrust here is a unified database to create an IT infrastructure where we have one singular data repository, and we have these different functional areas that all use that data. And at the top of this diagram, you see we have business intelligence systems dashboards, which can be used and referred to in an ad hoc manner. In other words, whenever we need it, and in a highly user-friendly graphical way that's easy to interpret. So an example of a transaction processing system is an ERP. All ERP, or enterprise resource planning systems, are transaction processing systems. ERP systems are designed to correct a lack of communication between the functional area information systems. For example, in marketing, promotional analysis involves identifying the best advertising channels. Similarly, we use information systems to integrate different organizations in the form of interorganizational information systems, the different chains or different steps in the supply chain as well. Table 1.4 offers another way to organize information systems. This is based on how information systems support decision making. So you can see in here we have our transaction processing systems and enterprise resource planning. These are going to integrate the different functional areas. We also have management information systems. This has the purpose of supporting middle managers. Decision support systems similarly can be developed for top management interests, but lower level managers can use this system so that the organization can operate more powerfully and more efficiently by pushing the decision down to a lower level of decision maker in a much more economic way. As I mentioned, expert systems, this is an attempt to mimic human expertise in the system and requires a special developmental approach. We also have executive dashboards that I mentioned earlier. This presents oftentimes ad hoc status checking by top managers, allows them to drill down through the entire organization, but these systems also have to be very user friendly. They also offer real-time feedback, so they are very high-end sophisticated systems and represent the most modern types of systems. Section 1.3 is about how IT impacts organizations. In fact, IT impacts entire industries. For example, Amazon used software to disrupt the previous market-leading companies in the book industry. And now, of course, Amazon sells a whole lot more than books. LinkedIn is a fast-growing company that is disrupting the traditional job recruiting industry. The national defense industry is currently using drones as part of its business model. We see these changes over and over again, and I mentioned earlier that doctors are using robots to mitigate their surgeries, issues with that, but also we have farmers using IT to make chemical dispersion on the farm more efficient, and they're automatic cow milking stations. We see information technology throughout many different industries. IT has in fact created an industry. You can see here from these images that we now have ergonomic devices because of the physical impacts of IT on the human body. People sitting still, many of you may have these issues. We need back support, we need to stretch, we need foot support, for example, we need wrist support. So the science of designing machines and work settings that minimize injury and illness is called ergonomics. And ergonomics, of course, people who study this are certainly into designing products that support IT users. IT impacts entire industries, but let's look at how it impacts organizations. If you look at this diagram, it's very simple. Has green on the bottom. This is operations management at the bottom. Yellow is tactical management. At the top is strategic management. Very simple kind of cartoonish diagram. You can see from this that we have most of the people at the bottom and presumably a really smart person at the top, usually very experienced, an older person. And what IT has done for organizations is that it has cut out the middle management, because historically middle managers have been responsible for creating reports from to communicate, from serving as liaisons from the operations management at the bottom to the top. And we don't need them anymore because we have decision support systems, expert systems, executive information systems. So these middle managers handle tactical decisions, meaning decisions from 0 to 1 year out. Now we're having information systems pretty much handle all of that information workload. IT changes the nature of managers' jobs as well in many ways. Number one, it allows managers to manage more functions, more product, more operations, and it also provides near real-time information so managers can make quicker decisions. So as you can see from this example, IT is making organizations more competitive and more real-time. There continue to be articles written about the fear of IT eliminating jobs. As you can see from recent history, the unemployment rate was recently at 3.5%. And we've never had more information technology than we've had now. Of course, with the virus that happened, the unemployment rate is expected to skyrocket, but that's an economic externality that has nothing to do with the value of information technology. That's because people are not interacting. In fact, because of that, IT jobs are really exploding. If you look at Zoom, this Zoom technology, it's exploding right now. So you can see that workflows have been greatly disrupted, and thankfully we have information technology to help support that. So in fact, the virus, the COVID-19 virus, may actually work to boost some IT jobs. But it's a myth that IT is costing jobs based on that recent history. As I mentioned with ergonomics, IT is known to affect employees at work. It's going to affect their health and safety. A wonderful thing about IT is that it enables many people to work. People with disabilities. We've had students who were quadriplegics, people with serious vision problems, who used specific IT tools, peripheral devices, to function as well or better than anybody else. So we have graduates who are quadriplegics who have full-fledged careers in IT, book authors, etc. That are mediated by information technology as well. IT is also affecting our quality of life in numerous ways. It allows many to work from home. And this is both a benefit and a curse of IT, because if you work at home, you're not actually interacting with your coworkers. Of course, with the virus that we've had, that has not been possible. But at any rate, people have telecommuted. Telecommuting has exploded. We now have uh, remote faculty at universities. It's a very common class of faculty now. A faculty member may live in Colorado and work at a university in Tuscaloosa or Auburn or Athens, Georgia, or Starkville, Mississippi. So telecommuting has reduced traffic. It's having a huge impact on people's quality of life, and you can argue it's reduced the pollution as well. WebMD is another example of it affecting IT affecting quality of life. It's an attempt to represent expertise that allows doctors to diagnose diseases. IT allows the workplace also to expand to 24 hours a day in any location, which is a benefit for employers and employees. I mentioned the Da Vinci robot. Robots are having a revolution right now. Robots are useful for handling monotonous tasks such as factory work. 70% of industrial robots are utilized in automobile factories. Rethink Robotics' stated goal or mission for Baxter is to rescue U.S. manufacturing through technological innovation. Baxter is an industrial robot that improves upon existing technology by being less expensive and easier to work with. And there are now warehouses that are 100% fully automated. And interestingly, these exist in Memphis, Tennessee, where FedEx is located. So as you can see from this, they want to completely automate warehousing work and shipping and make that as efficient as possible throughout the world. So it's a very ambitious goal, and many companies are achieving this with information technology. Information technology is being credited with improvements in healthcare. This lovely lady is my wife. She is in nursing informatics, and she loves all this information technology in healthcare. It's called HIT, Health Information Technology. For example, Apricot Forest addresses problems in the Chinese medical system. It's a medical journals app that was designed by Apricot Forest to help physicians stay current on the latest research literature. This is in another one of the cases that are in this section. The chapter closing case is about drones. The book says that the United States is the least supportive of drones, as evidenced by their regulations supporting drone integration. As of February 2015, the FAA had granted a total of 24 exemptions for the commercial use of drones and had received 342 requests for exemptions. The FAA proposal for drone use does not apply to recreational activities for which the FAA had already issued a policy. I suggest you read that case because drones are very important, not just for photography, but we need to look at things. There was an example of drones being used in a massive construction project in San Francisco where they were building a subway. They used drones to go around and look at different points in the construction site. They were concerned about safety issues and, of course, materials and inefficiencies. So this is the end of the first chapter, and I hope that you feel more comfortable, a little more comfortable with information technology. We're going to expound on a lot of this in the future, and some of it will be redundant, but that's okay because that will facilitate learning as well. And that's the end of this chapter. Thank you.